All right, welcome everybody. Today we're going to talk about section 7.3. And the truth is, to be successful in the remainder of chapter 7, you have to be really, really good at factoring. We have spent a lot of time this year reviewing all the different types of factoring, and we're going to spend even more time today going over those. After we review factoring, we're going to go ahead and simplify rational expressions. In order just to kind of keep it clear what it is I'm talking about as I go through these problems, I want to point out some important chapter 7 vocabulary. So first of all, a polynomial is the sum or difference of monomials. Basically everything along the first column here, those are all polynomials. Those are what you're going to be factoring. Then a rational expression, you saw some of those in the previous section. So the rational expression is once you make a fraction whose numerator and denominators are polynomials. I am going to ask you for the domain of a rational expression, which means all the real numbers except for those that make the denominator 0. I know that we're used to giving domain in interval notation, but because there are often a lot of restrictions in these problems, I'm going to show you kind of a little shortcut. And then finally, the thing that you are most trying to do is put a rational expression into what's called reduced form. And that is when you have canceled out any common factors to the top and bottom, and the numerator and denominator no longer have any factors in common. So I say again, in order to be good at not just this lesson, but the next couple of lessons, you have to remember all the different types of factoring. So if you take a look at the notes, I separated them into a left side and a right side. On the left side is where we're going to be doing all our factoring review. Then on the right side is where we're going to be doing all our simplifying and stating the domain. For tonight's homework, it is not separated. It's just the right-hand side because we assume that after the lesson, it will make sense. But just FYI. Before I get into it, one other thing. Your teacher probably sent you a copy of this factoring review table. This is basically a summary of all the different types of factoring that we learned this year. And again, not just what you're going to need to know for this lesson, but what you're going to need to know for next year and assessments. So a really handy tool that I strongly suggest you print out if you haven't already. Over on the left side is the name of the method. In the second column is a clue for when to use it. Then in the third column is how to use it and helpful hints. And then in the final column is examples. So as I refer to the methods by name today, if you have your factoring sheet handy, you might want to look at it. And then certainly this is a great resource for you anytime going forward. I'm not going to go through it with you since I assume you can follow it on your own. But again, I think that's going to be really, really helpful. So let's get into the actual lesson here. So take a look over on the left-hand side, and you're given something that's actually pretty simple, 5x minus 35. In order to factor something like this, all you're going to try to do is factor out a greatest common factor. A greatest common factor of each term would simply be a 5. If you factor out 5, you're left with an x minus 7. So if you take a look now over on the right-hand side, you're going to take your rational expression. You are going to leave the 5x on the top, and you're going to rewrite 5x minus 35 in its factored version. After you factor and rewrite, you are trying to simplify. So simplify means you want to cross out anything common to the numerator and the denominator, which in this case means I can cancel out the 5s. So I'm left with just an x on top. I'm left with an x minus 7 on the bottom. And this x minus 7 has to stay together. You can put parentheses around it if you want, but you are no longer allowed to cancel anything. So you cannot reduce the x on the top with that x in the bottom. So that is your final answer. And then to finish, it asks you to state the domain. So when it asks you to state the domain, you basically have to go back and you have to look at every single version of the denominator. If there was ever any value of x that would have made the denominator 0, you have to say x cannot equal that value. So the only restriction here is x cannot equal 7, because if you put a 7 in any of those steps, you would get a 0 on the bottom. That's not allowed, so we call it a restriction. So these first couple should go relatively quickly since the factoring is pretty simple. Take a look here at number 2. You're again going to try to factor using just a greatest common factor. That's what we did in the first one, and we're going to do that again here in the second one. So the greatest common factor is not just a 3, but also an x. If you take a 3x away from a 3x squared, you're left with an x, and then plus 3. So if you take a look over here on the right-hand side, you're going to rewrite the numerator as the factored version. And then notice the denominator is just a 12 and then an x cubed. You just want to realize that that 12 and that x cubed are separate, which means you can reduce those one at a time. You also want to review that this x at the top is just x to the first. So as you go to reduce now, again, you're going to cancel anything common to the numerator and the denominator. So I'm going to start with the 3 and the 12. I can reduce the 3 and the 12 both by 3. So the 3 on the top cancels to be a 1. The 12 on the bottom reduces to be a 4. Then I'm going to cancel the x's. So I have 1x on top and I have 3 x's on the bottom. Where are there more x's? On the bottom. By how many? 2. So I'm going to make that a 4x squared. And then there's nothing that I can cancel with the x plus 3. So the x plus 3 is going to stop. And so the 1, you can leave it there or not. If you have an x plus 3, you don't need to put the 1, although it's fine if you do. So this is a perfectly good answer, x plus 3. Again, if you wanted to put parentheses around that, you certainly could. You just want to make sure you understand no more cancellations are allowed. And then in your final step, you want to go ahead and state the restrictions. And again, restrictions in this case come from the denominator. The denominator has a variable of x. The only value of x that is not allowed would be 0. If you put a 0 in any step, it's going to give you a 0 in the denominator, which is not allowed. So how about here in number 3? So in number 3, the truth is there really isn't anything to factor. All I really wanted to point out here is that this is really 9 times x squared times y to the first times z to the first. So you can kind of think of each of those, values as their own separate quantity. Same thing with 24 times x to the first times y to the first times z squared. So again, I just really want to point out here that you can go ahead and reduce each value one at a time. So over here on the right, again, really nothing to rewrite. All I'm going to try to do now is reduce, starting with the 9 and the 24. So while they don't reduce completely, I can divide each by 3. So if I divide the 9 by 3, I'm going to get 3, and 24 divided by 3 is 8. Then when I look at x squared and I look at x to the first, where are there more x's, on the top or bottom? The top by 1. If you take a look at the y's, because they are exactly equal, I can just cancel those y's out altogether. And then as I look at the z's, where are there more z's, top or bottom? Bottom by how much? By 1. And you don't have to put z to the first and x to the first. Again, it's just there if you want to. In terms of the restrictions, because there's an x on the bottom, because there's a y on the bottom, and because there's a z on the bottom, all of those have to be restrictions. And in this case, none of them can equal 0, because if you put a 0 in for any of them, it's going to turn the entire bottom to 0. So obviously, as we proceed, these will get a little bit more complicated, but nothing that I don't think we can handle. So here in number 4 and the first one and second one, we are going to still be using the greatest common factor. So the greatest common factor of 3a cubed minus a to the 4th is a cubed. That's going to leave us with 3 minus a. The greatest common factor in the second pair is both a 2 and an a squared. So 2a squared times what is a cubed? That's a, and then minus 3. Again, the whole point of me setting the notes up like this is so that you could now very easily take your fraction and simply put in the factorization, whereas tonight you're going to kind of do that in one step instead of 2. So now again, I want to go ahead and try to reduce anything that I possibly can. So in order to do that, I'm going to first look at this 2. Because this 2 is all by itself, there isn't anything to cancel it with, so I have to keep a 2 in the denominator. When I look at the a's, a to the 3rd over a squared, where are there more a's, top or bottom? It's the top by 1. And then something super, super interesting. Look at 3 minus a and look at a minus 3. I hope you would agree those are not the exact same thing. But what they are is exact opposites. So if you ever see a case like this where you have what I would call exact opposites, they reduce to -1. So basically, you're allowed to cancel these out, but you're left with a -1, and you should put your -1 up top in front of the a. You could just put a negative instead of a -1. It would work the same either way. So here's my final answer, -a/2 or -1a/2. In terms of my restrictions, so my restriction is in this case are on the a values. So a cannot equal, if I look at this, a cannot equal 0. And if I look at this, a cannot equal 3. Again, just to kind of point out here, again, a little hint and reminders about canceling. If I was to say to you x minus 2 over x minus 2, those are an example of a problem where they are exactly the same. So I could cancel those completely and be left with a positive 1. Compare that to if I had x minus 2 versus 2 minus x. Those are not exactly the same, but they are exact opposites. The opposite of a positive x is a negative x, and the opposite of a -2 is a positive 2. So if you ever see a pair of exact opposites, those are going to cancel to be a -1. So I think that is going to be really helpful going forward. Let's try a couple more. So here in number 5, starting with 3x minus 5, you're going to factor out the greatest common factor, which would be 3. And then we see a trinomial. Notice that out front is just a 1. So this is a trinomial coefficient of 1 compared to the top one, which is a GCF. And again, I note that just in case you want to use your factoring chart. So if you have a trinomial with a coefficient of 1, you're going to have 2 parentheses, whatever the variable is. Then you're going to need to find 2 numbers that multiply to be the back and add up to be the middle. So I'm looking at 5 and 2. If they have to multiply to be positive 10 and add up to be -7, we're going to be looking for a double negative. So again, we're going to go over to our right-hand side. We're going to replace the top with 3 times x minus 5, and then x minus 5, x minus 2 on the bottom. Here's a little tip for you. If there are no common factors, this is a pretty boring problem. So if you're doing your homework tonight and nothing is canceling, that's an issue. It probably means you're factoring incorrectly. So in terms of reducing, I have this x minus 5 and I have this x minus 5. So I also have this 3, which has no friends, so he's going to stay. Because these x minus 5s are exactly the same, they're going to cancel out to just be a positive 1. And then I'm going to be left with an x minus 2 on the bottom. And again, you could put that in parentheses if you would prefer. Then you have to make sure that you state your restrictions. And again, when you state your restrictions, you have to check all of your denominators, even if they got canceled out. So x cannot equal positive 5 or positive 2, because if you chose those values, the entire bottom would cancel to be 0. So hopefully you're kind of understanding the technique. Hopefully these factoring methods are kind of coming back to you. There are a few slightly more challenging methods on the back, so let's go ahead and do those. In number 6, these are kind of just, again, trinomials with a coefficient of 1. In both of these cases, you're going to factor them as x and x. It's possible that there could be some that don't factor, although again, we're not really going to see those because that's pretty lame. Factors of 18 that add up to be 7 would be 9 and 2, and it would have to be a negative positive. Factors of 9 that add up to be 8 would be 9 and 1, and it would have to be negative positive. If I go ahead and replace, so x minus 9, x plus 2, and then the denominator. Again, if you have any pairs that are exactly the same, you can cross those out entirely. It just reduces to be a positive 1. So you're going to be left with an x plus 2 up top and an x plus 1 on the bottom. Again, feel free to put parentheses around those if you want. There are no more reducing that is allowed. You cannot cancel those x's because of the x plus 2. Those have to stay together, and the x plus 1 as well. What are your domain restrictions? So x cannot equal. You have to check all of your denominators. So it's always the opposite, which in this case would be positive 9 and negative 1. Our last 2 examples here, or last 3 rather, focus on some more of the challenging methods. So here in number 7, notice that you have a trinomial, but notice that you have a coefficient that's greater than 1. So that means you're going to have to use our old friend, the AC method. So as a reminder, the AC method says you're going to multiply the A times the C. So 6 times 3 is 18. You need two numbers that multiply to be 18 and add up to be negative 19. So factors of 18 that make a 19 are going to be 1 and 18. Because they have to add up to be a negative, you're going to make them both negative. And then remember, the whole point of doing this is you're now going to split up the middle term. So 6x squared minus 1x minus 18x plus 3. You're then going to use grouping, which means group the first two, group the second two, and pull the GCF out of both. So the GCF of 6x squared minus 1x is just an x, which means you're left with a 6x minus 1. When you have a negative for your third term, make sure you factor out a negative. So when in doubt, factor the negative out. So you're going to factor out a negative and then a 3. So that's going to leave you with a positive 6x and a negative 1. Hopefully you remember that these guys should be the same. And if they are the same, that's half your answer. Sorry, class notebook issue. So if they are the same, that's half your answer, 6x minus 1. And then whatever's on the outside is your other answer, which is x minus 3. And you can write them in either order as long as those are your factors. So I'm going to go ahead and write that over here. So 6x minus 1 and x minus 3. Then for the denominator, or not the denominator, for the next one, 4x squared minus 36. The first thing I hope jumps out at you is the fact that 4x squared minus 36, these do in fact have a common factor. Again, sorry, a little class notebook frozen there. So 4x squared minus 36, you're going to go ahead and start by factoring out the greatest common factor, which is 4. If you go ahead and factor out the 4, you're going to be left with an x squared minus 9. Then hopefully you recognize this as our old friend, the difference of squares, which the difference of squares, don't lose the 4, is always going to be 2 parentheses, 1 plus, 1 minus. Then you're going to do the square root of the front. Sorry. So then you're going to do the square root of the front in the front. And you're going to do the square root of the back in the back. So make that purple. So the square root of x squared is just x. The square root of 9 is 3. So that means you're going to factor your denominator as 4 times x plus 3 times x minus 3. When it comes to cancellation, I can cancel this x minus 3 with this x minus 3, which means I'm left with a 6x minus 1 on the top, a 4 and an x plus 3 on the bottom. I'm going to leave everybody exactly as they are. Don't multiply. No more canceling is allowed. And for the final step, what are your restrictions? So x cannot equal. Check both of your denominators. Turns out I can't have negative 3 or positive 3. All right, so our last two problems here, and in number 8, we actually kind of went back to simpler ones. So for the top, we're going to use the GCF strategy. So I'm going to factor out a 5, which leaves me with an x minus 2. And then in the second one, this is still the difference of squares. Normally we see the variable first, but I promise it works the same way no matter the order. So again, because 4 is a perfect square, I'm going to put the square root of the front in the front and the square root of the back in the back. Because x squared is also a perfect square, I'm going to put the square root of x in the front and the square root of x in the back. And then difference of squares means one is always positive and one is always negative. So 5 times x minus 2 up top. 2 plus x times 2 minus x on the bottom. In terms of trying to cancel, if you look carefully, you don't see anything that is exactly the same. But what you do see is x minus 2 and 2 minus x. Remember that while those are not exactly the same, they are a pair of exact opposites. So nothing cancels with the 5. Nothing cancels with the 2 plus x, but because the pinks are exact opposites, I can cancel them out and I'm left with a -1. When you're left with a -1, you pretty much just put the negative up top. Then your restrictions, check all of your denominators, even the ones that you cancel. So x cannot equal +2 nor -2. For our final example, we'll do the second one first. The second one is, again, the difference of squares. So 2 parentheses, square root of the front in the front, square root of the back in the back, 1 positive, 1 negative. Order doesn't matter. And then the only time we've seen it today, x cubed plus 64. You may or may not realize that that is the sum of cubes. If you take a look at your factoring table, there is the sum of cubes and the difference of cubes. Remember, in order to be a sum, you need addition. A difference is a minus. Cubes means you're going to have something to the third power, and then you're going to have the perfect cubes. So again, your chapter 5 cheat sheet might be helpful as well. The formula is on your sheet, and as a reminder, it is a cubed plus b cubed. Says you're going to factor as a plus b, a squared minus ab plus b squared. And again, this is on your formula sheet. You do not have to memorize it, not now, not ever. But in order for it to work, you have to first write it as something cubed plus something cubed. So what would you cube to get x cubed? That would be x. What would you cube to get 64? That would be 4, which means that this is your a and this is your b. Per the formula, you're going to factor it as a plus b, which would be x plus 4. Then you're going to square the a, which means square the x. Then you're going to multiply a times b, which would be 4x. And then you're going to square the b, which means square the 4. So you're going to take both of these factorizations and put them on the right-hand side there. Again, this is the only sum of cubes we've seen today. Remember, there's a difference as well. So taking a look here, if you're looking for anything that is exactly the same, I see those x plus 4s, and I'm going to cancel them, which means I'm left with a numerator of x squared minus 4x plus 16 over x minus 4. And that is as far as I can go. A little reminder here, when you're doing the sum or difference of cubes, you are always going to wind up with a quadratic that cannot be factored any farther. So you never have to worry about it. You just know 100% of the time it's never going to go any farther. And then finally, your restrictions. So check all the denominators. X cannot equal -4 or +4. So for tonight's homework, essentially, I just give you the right-hand side, which means you're going to factor and reduce all in one step. Please make sure you use these notes along with your factoring table, and we will catch you next time.